Hi, welcome to Ethereal Mechanics video number 25. This is the second video on Distinti's universe. We're going to talk about the oceans of Earth and Mars. If you want to know more about Ethereal Mechanics, go to the channel trailer or look at video number 1. This Distinti's universe series is a small segment of videos which I intended to put at the end, but I needed to put it in the middle to get it out of the way because I'm spending too much time thinking about this stuff because it's more fun than it is really practical. The later stuff in Ethereal Mechanics is going to be all hardcore electromagnetic stuff. Anyway, this is a long video, so let's go on. There are 4 mysteries of the Earth: oceans, life, crude oil, and granite, where Earth is the only known source of granite. And the Earth is the only place where these things are known to occur in mass quantity. But let me diverge for a second. I have a little pet theory I call the life theory. Life imitates the foregone Earth. And the reason why I got foregone in there, because if you take out foregone, it's L-I-E, the lie theory. So I had to put something in there to make it not a lie theory. But there's an interesting fact that blood plasma is nearly identical in salinity, pH, and trace minerals as seawater. In fact, in World War II, purified seawater was used as a plasma substitute. But this is only logical, that if life evolved on this planet, that the chemical processes of life would be spin-offs of chemical processes that occurred on the Earth at the time. I mean, this is logical because obviously if we evolved on this planet, we would not evolve as chlorine-breathing creatures, or mercury drinking creatures, because those things just don't exist in quantity on this Earth. And consequently, the machines that we develop also mimic or complement these processes. And you can look at these 2 examples down here. I'm not going to read them for you. But let's use some reciprocal thinking. If Earth chemistry influences life chemistry, then can life chemistry influence Earth chemistry? Yes. The Earth was terraformed by life. That's why we have an oxygen atmosphere. And I'm going to show you that the same process also gives us the oceans. Yes, the oceans. And this life theory will be a recurring theme through the remainder of this presentation. I probably will not refer to it beyond this point because we've got other things to go on to. So let's go back a second. Let's look at the mysteries. The consensus thinking among scientists is the oceans came from comets. From the ocean sprang life, and from life came crude oil deposits. Well, in video number 20, I show you that humans usually get stuff backwards before they get it right. And the example 1 is Galileo. In the beginning, they thought that the stars went around the Earth. Now we realize it's the Earth that's stable, and it's the stars that stand still and the Earth that spins. Another example is back in the early days of medicine, they thought that the rays came out of your eyes and struck the distant objects, and that's how you saw things. Just like if you went out and touched something. So your eyes basically used a braille ray, I guess you would call it. Now we know it's completely the opposite way, is that ambient light enters your eyes. Okay, now I'm going to make a reasonable argument that the other things happen the other way around. Okay, before I explain my backwards view of the universe, or the world rather, let's look at the present understanding of these phenomena. Let's start with the oceans. Scientists are not sure where all the water came from. A theory is that an oceans came from comets, and they have arguments against it because the nuclear elements, the marker elements, I guess, are different in comets than they are for the water on the Earth. But they don't know if the few comets that they have sampled are the same as the rest of the comets in the Kuiper Belt. My argument against it is simple. If comets brought all the water to Earth, then they'd bring all the water to all the other planets too, and all the other planets should have significant water content. And they do not, except possibly for Earth, Titan, and Europa. I mean, if all this water fell on Earth, why didn't all the same amount of water proportionally fall on Mars or the Moon? So it couldn't have come from comets. And later, I will show that the oceans, like the present-day atmosphere, are byproducts of life. Crude oil. Internet reviews suggest that scientists are not really sure. The best evidence points to a biogenic source. Biogenic means generated from bio, from life. And the reason why they do this is because we know that methane comes from bio, because we fart methane. Coal comes from bio. We have good evidence on that. And so they said, well, why not oil too? I mean, you know, heck, we got nothing better to go with. So it's guilt by association. So let's use some logic. If we truly understand the origin of fossil fuels, then we should be able to mimic the processes in a laboratory. Let's look at coal first. Coal is nearly 100% carbon. Well, I guess it depends on grade, but if it completed it, it would be 100% carbon. Okay, and we humans can roast wood in a kiln and create charcoal. Charcoal is nearly 100% carbon. Charcoal is a coal substitute that you can cook on, because regular coal being in the ground has a lot of toxic chemicals like mercury and lead, and so you don't really want to cook over coal unless it's in like a oven that separates the flue gases away from the food. But we can definitely cook our food over charcoal because we make it from wood. Okay, and charcoal, if we just were to compress it, it would look just like coal. Okay, but we know the process of compressing will work and all that stuff, so we're good with I'm good with that. Okay, and also we've been mimicking the creation of charcoal for thousands of years. It's not a complicated process. And additionally, coal has fossil evidence. Here's a picture of the top of a coal mine. When they pulled all the coal down and exposed the rock roof, the plant that was on the top actually fused into the ceiling from being compressed down on top of the coal pile from the mud that buried everything. So I mean, it's like it's lock, stock, and barrel. We can say definitely that coal is definitely a fossil fuel. And this is the credits for the picture. Okay, methane. Humans fart, which proves that biological organisms can create methane. We've been doing this since forever. But Jupiter, Saturn, Uranus, and Neptune have extremely thick atmospheres of hydrogen, helium, and methane. Where did that methane come from? Is there a pig farm on Jupiter? If the planets can produce methane on their own without any life, then methane is a product of both life and other planetary processes. So let's get back to crude oil. If crude oil was the product of biological processes, we would have mimicked that process thousands of years ago. Remember video number 8. Science is nothing more than monkey see, monkey do. Okay, science has no clue where or how the crude oil got here. Otherwise, if we did, we would be turning corn into gasoline instead of alcohol to fuel our cars. But we're close. I mean, we can power a diesel engine with vegetable oil, but vegetable oil is not a hydrocarbon. Okay, vegetable oil is a ester. Okay, and we can transform it into hydrocarbons, though, with either of the two processes. With a hydrocracking, which is a catalytic cracking process assisted by the presence of elevated partial pressure of hydrogen gas. And that way we can transform it. The other method, which is brand new, is they invented a genetically modified organism which can transform glucose into biofuel gasoline that does not need to be blended. So great, we have stuff that probably could not have possibly existed on the early Earth, which is a hydrocracking process and a genetically modified algorithm. Great. So that could not, very unlikely that stuff occurred in the early Earth. But consider this. Vegetable oil, being an ester, is somewhat similar to a diesel, a cetane, and scientists are trying to transform vegetable oil into a hydrocarbon. However, vegetable oil is produced by transforming a carbohydrate through photosynthesis, produced by photosynthesis. Well, maybe crude oil might be created in a similar process. And recapping, photosynthesis creates carbohydrates, and then in the plants the sugars are converted to oils. Let's look more close. Hydrocarbons look more similar to carbohydrates. Here's hexane, which is a hydrocarbon, which is a fuel. Here's glucose, which is the product of photosynthesis. And here is the vegetable oil. This chain actually goes down, and it's actually triglyceride. There's 3 of these side by side. But this is a much more complicated process than either of these, or a complicated molecule. Actually, this looks closer to this. If life is a spin-off of early processes, and this is a photosynthesis process, this looks like a much simpler, earlier process, and why couldn't photosynthesis be creating this directly? I mean, in the early Earth, there was no oxygen in the atmosphere. Now, since hydrocarbons look like a form of carbohydrates, and carbohydrates are formed through photosynthesis, and life processes are a spin-off of Earth chemistry, perhaps there's a primordial photosynthesis that occurred in which hydrocarbons were or are produced. Let's take a look. So what is crude oil? Well, crude oil is all these carbon-hydrogen chains, and they can be any length long, and they can even start in the middle, and they can go off, you know, and they can be all kinds of different shapes and forms, and one chain stuck into another chain like Frankenstein. Octane, I believe this here by 1, 2, 3, 4, 5, 6, 7, 8. This with a hydrogen here, that would be octane, which is 8 carbons. Hexadecane, okay, is 16, and that's diesel. And then as you go heavier and heavier and heavier into lubricating oils, you get very, very long and complicated chains. And a mixture of all these things together is what crude oil is. So let's go back to pre-tectonic Earth that we described in video number 24. In pre-tectonic Earth, after the Earth lost most of its, after the collision and the Earth lost most of its atmosphere, what you had is the sun exposing the now cooler surface of the Earth, and you had carbon dioxide and methane, helium and nitrogen venting from the cracks. The magma's down deep, and there might be some sulfur dioxide, I don't know. But interesting thing about these two chemicals here, those are what they call greenhouse gases. Again, we're going to get a whole thing about global warming. That's getting to be ridiculous. But the reason why they're interesting chemicals is because they're easily ripped apart by light. In other words, they can be heated up to dissociate in the presence of direct or intense sunlight. And I believe that the sun was a lot more intense back when this happened, and maybe even a little bit off color, more toward blue and more ultraviolet. But you know, that's another theory when we get to the sun part. And so what happened is you had methane atoms and a carbon dioxide atom. I'm sorry, molecules. Sorry, I get my words mixed up all the time. And if you were to, these were close enough, and you were to break this guy off and break this guy off and break this guy off, then they might form together and pull apart. And then what you have now is ethane, water, and carbon monoxide. And then if you do it again, okay, you've got propane and 2 water and 2 carbon monoxide. And you do it again. The chain keeps on growing. Now they don't have to keep growing end on end. They could grow in and out any which way you want. And then you have butane and 3 waters. And then you go to pentane, 5 anes. What's in an ane? Which gives you 4 waters. And I'm not showing the carbon monoxide anymore. And you can do it again. You get hexane. And that's still a gas. And then you get to heptane, which is a liquid. At least at today's environment it is. And now you start having chains of hydrocarbons raining from the sky. And octane, which is gasoline. And so in the early Earth, you had an early water burst. It rained crude oil, actually the lighter elements of crude oil rained out, and it rained water. But there's not enough water for an ocean. This early water precedes the oceans. But now what happens is, it's hard to see, there's these lakes of crude oil, and the water sinks down into the cracks. Some of the crude oil might go into the veins, but the sun is still exposing this crude oil, and there's still methane and carbon dioxide bubbling up. So these chains are going to go to higher and thicker and thicker and thicker and thicker and thicker chains, and that's producing more and more water too. The water now sinks down into the cracks where the magma chambers are, and it starts picking up salts, and that salts, along with the heat from the magma, start leaching the iron and calcium out of the basalt, and that's where the formation of granite begins. And because granite is porous, this formation can start transferring into the rock. It doesn't have to stay right around where the magma is. It can start the heat and the salt water can start leaching through the rock, because granite is porous rock. And an interesting thing is that the early water is similar to blood. Remember the argument I said at the beginning. I said only the pH level. Well, guess what? This early water is leaching out iron and calcium, and it's going to have a significant iron and calcium ion content. We go on. So if we look, in order to make granite, the hot salty water had to leach out iron, calcium, and magnesium oxides. Well, in basalt, you have a very high iron content. It's about 1 to 1.5 times the amount of calcium, and you have equal calcium and magnesium contents. In human blood, you have 10 times the amount of calcium, but your calcium magnesium contents are about the same. So it's feasible. Okay, life isn't stupid. Okay, people automatically assume that the first life formed where the sun struck the earth. And that doesn't make any sense to me. If life wants energy, the energy is down here where the magma is. That's where going to be the most intense energy that life could be able to find. That is, to me, where life should go. They're going to go where the most energy is. Okay, and the most nutrients are going to be down here as well. But once life starts, water production goes into overdrive. Small microbes deep in the earth metabolize methane produced from the mantle and oxygen from the metal oxides in the basalt and release water as a waste product or something like that. And then the water transport the metal ions back down where they are released into the magma and can return to the core and recycled in a certain sense. Because the crust is being lightened, it rises, which allows the upper layers to cool even more. But in order to do that, life has to go deeper, because as the crusts get lighter and they start rising, okay, the magma plumes start deepening, and the magma plumes deepen, so the life forms have to go deeper and deeper. And I call this the deep life theory. The crust becomes so cooled that they become brittle and crack into large continents. Those are the continents that we know today. But things change. Once the large granite plates crack, okay, it begins as a small gap between them. Sorry for the exaggeration of the wide gap. All of the aquifers of water empty out into this new crack, and that allows the remaining, most of the bulk of the surface crude oil to sink down into the aquifers that are now vacated by the water. If there is any more aquifers with water, they're going to be below, or they're going to be in different areas. Now what's going to happen, as the plates start expanding because of this convection action here, the bulk of the water production is now going to occur at the crack, at the tectonic plate where they're expanding. We got a more detailed slide of that later. But the interesting thing that happens at this time is, because the plates have expanded so much that the lava plumes are so deep now, except for the few that come up, that the surface now is very, very, very cool, and the life forms that got stranded there, for lack of a better word, now are isolated from the lava plume energy. So that the only energy now is from the sun. That is the bulk energy source available to surface dwelling creatures. And so therefore, the only source of carbon also is the carbon dioxide from the atmosphere, or any of the surface crude oil that remains. And those creatures then adopt a photosynthesis process similar to the way the crude oil was made, and they start taking the carbon dioxide and breaking that down into oxygen, producing the oxygen atmosphere. Oh, it's an O, not a Q. Any unsealed surface crude, and the crude oil deposits from the few volcanoes that are available, they get sealed in with magma flows. Any of the crude oil that is remaining either gets metabolized or set on fire. Now, because of lightning with the oxygen, could set the crude oil deposits that are on the surface on fire. Later, surface carbon becomes depleted. Now the only sizable source of carbon on the surface is other life forms. So life forms evolve which eat other life forms to get that carbon back recycled. Then sooner or later an ice age occurs. Green matter becomes in short supply. herbivores begin to eat each other. This is the evolution of carnivores. So let's do a wrap-up. Life is found in mass on the Earth. So too is water, the oxygen atmosphere, granite, and crude oil. These are not known to exist in any quantities anywhere else, except for the possibility that Titan and Europa have a significant water layer. And that would be interesting to search for deep life and or significant granite deposits. Now, there are many scientists who believe that life began near hot magma. If you do on the search term, go on Google and search hydrothermal origin of life or dark life, you're going to get there's a lot of even books written to this fact. Or not fact, but to these theories. My D-life concept takes life deeper into the Earth, and it's prior to the advent of large oceans. Okay, this deep life increases the conversion rate of basalt to granite. And this results in more violent plate tectonics because we're creating granite at a much faster rate and much more pure granite than with the standard Earth processes that existed before life. Also, a much faster water increase, much higher increased rate of water production as well. And these predated the transformation of the atmosphere to oxygen, nitrogen. Now, I didn't get much chance to get into Mars because this presentation got so large that I decided just to short the Mars section of this. Just to give you a little detail, Mars is a subset of the Earth. The initial water burst did occur. Life began the terraforming process, but Mars's hot core was too small, and because of that it had a short cook down period and it ended way too soon. So the water production stopped, life stopped, and Mars has been losing water and atmosphere ever since. Okay, what's next? The next one's going to be a big one about the sun. I'm going to show you the bulk of our understanding of the sun is backwards. After that, we're going to have a short one on planetary orbits and precession. And these are very high conjecture ones about black holes and a new material I call galaxium and galaxies and the multi-universe. After that, everything beyond that is going to be hardcore math and hardcore models, and we're going to be concentrating solely on electromagnetic physics, which is my expertise. So this fun stuff I'm getting out of the way so I can get it out of my brain so I can concentrate on this stuff 100%, because I love going back and thinking about all this stuff. That's for homework for video number 27. The next video, if you go to YouTube and you search for Secrets of the Sun, you're going to find a BBC production, and they're going to talk about sunspots, the magnetic fields of the Earth. And the thing that drives me nuts, absolutely drives me nuts, is they always say all these big prominences on the sun, oh, those are magnetic field lines. And you always see matter flowing in these big chains. I'll say that's the sun. And it's twisting and turning and say, oh, those are the magnetic field lines. And I'm like, these people don't have a clue what magnetism is. I mean, F equals QV cross B. If you've got charged matter, okay, and you've got a magnetic field, matter, if the matter is moving this way and the magnetic field is moving this way, the motion of the matter is going to be orthogonal to the magnetic field. So if you've got charged, highly charged ionized particles moving in this path, that is not the path of the magnetic field. The only fields where the matter will move in the direction of the line of force are an electric field or a gravity field. Thank you for contributing. Please get the word out.